I'm really excited to talk to you today about the data that we use in GIS. So sometimes we call these data spatial data, sometimes we call them map data, sometimes we call them geographic or location data, but they all have one thing in common, which is, well, regardless of how you define it, it's the same thing. It's data that you can link to a place on the earth or a space. So they always have coordinates associated with them, an x coordinate and a y coordinate. And because of that, these data are all mappable. So any data that you can put on a map have to have these two attributes, an x location and a y location. There's a lot of examples of spatial or map data, and you've probably used some even today if you've used a weather app or if you've used a delivery system like Amazon or Uber Eats. All of these things are driven by spatial data in the background. During COVID-19, I think a lot of people were exposed to spatial data in a new way. So the Johns Hopkins University COVID dashboard was something that was viewed over 1 billion times, and it had the location of COVID cases. And it was used to make all kinds of decisions about public health. And maybe even if you didn't see the global dashboard, you perhaps saw one that was used in your region, something local to your city or municipality or county that showed how COVID cases were distributed and changing through time in your city. So it's just a recent example of really the power of spatial data and how useful it can be for decision making. But there's lots of other examples. So urban heat is something that's often mapped, and you can see that the colors that are used for mapping kind of give an indication that you have a hot spot or a cold spot of heat in a particular place. It's really trying to understand how things vary through space that is often so interesting and important to us. Here's a map that shows alcohol beverage spending in the US. So again, you can see how economic trends or patterns all different kinds, but here this is one just on spending on alcohol, vary across space. So you can see the different colors denote different kinds of values. I think an interesting thing is that sometimes we have location information stored as X and Y coordinates, but other times we will actually use place names. So you could have just a city or a state or a county that you use to record your spatial information. And because we have GIS data that has those boundaries mapped with coordinates, you can often link up spatial information that way in your data. So here's another map that shows air quality. This is also a really common example of spatial data. Quite often you might not have air quality measured everywhere, but you might have it measured at the airport, at schools, at different places around your city or region, and those can be mapped as points. So they can be samples that are linked to a particular location that measure something like air quality. The census data is one of the most commonly used spatial data sets because many countries have a census, so it's really common in Canada and the US to have detailed census data, and this is data that's collected regularly and continuously, and that we understand really well how that data is collected, or is at least documented so we could understand how that data is collected. And it provides us really important information on human populations, and we just has a ton of uses. So we'll kind of look at that more closely, and you'll have a chance to use census data in some of our examples. Okay, so there's basically two components to spatial data, and I've hinted at this, but let's just break it down a little bit. So all spatial data have location information. That's the X and the Y coordinates. It describes where something is. Sometimes we use place names instead of XY coordinates, but we use that because we already have those coordinates mapped in another way, so we can link things up spatially. And then most spatial data also have an attribute associated with them, so some kind of measure of the thing. So here is an example where you might have different cities or different countries, and that's the spatial information, and then the attribute information could be how many people live there, or the population density, that kind of thing. Here's an example just thinking about trees. So you might have a location, which is even a single tree, and then the attribute information could be the height of that tree, the species of that tree, the health of that tree. In city planning, we could have map data that is hospital locations, and associated with the hospital location could be the number of patients that hospital can hold, the hours it's open, the specialties that can be accessed there. So even actually, this just makes me think of a common example where if you're just trying to look, you Google where something is, and then up on your phone pops the location of that place, but it also provide business hours, whether or not, if it's a restaurant, you might get a picture that shows a menu. This is exactly the kind of thing we're talking about. So you can have a location that shows where it is in space, but then also we often need, additional information about that location.